Hello students, let us take a question from the topic collisions and center of mass. This question appeared in previous JEE mains question. The question as follows. A simple pendulum of length 1 meter has a wooden bob of mass 1 kg. So simple pendulum length is given, that is 1 meter. Mass of the bob is also given 1 kg. It is struck by a bullet of mass 10 power minus 2 kilograms moving with a velocity of 2 into 10 power minus 2 meters per second. So it is clearly mentioned the bullet gets embedded into the bob. The height to which the bob rises before swinging back. Okay. So of course it is a standard question. So I'll draw the first diagram related to this. So there is a simple pendulum. One bob is here and one bullet which is coming from here. The bullet is coming from here, which is coming with a velocity u, whose mass is also given, and this mass is also given. So this is what it's look like just before collision. How it looks like just after collision. Just after collision, it is in the vertical position only, but then now the bullet is inside the block. So now the bullet is here. So this entire system is now acquired a velocity v because of this collision. Now the total mass will be m plus m. Now after some time, this is no more in this level, it will be raised to some height. It will be no more in this level, it will be raised to somewhere here. Is raised to somewhere here. Okay, they are asking what is the height it is raised. So the height to which the bob rises before swinging back. So that means this is the situation after reaching here, it will acquire the velocity will be equal to 0. Okay, so how to solve this type of questions? The first idea I will apply here, conservation of linear momentum along the horizontal direction, which is perpendicular to the string length. So conservation of linear momentum means before collision, after collision, it will be same. So after collision, just after collision, I can say just before the collision. So just before collision and just after the collision. So just after the collision, the combined system is moving with a velocity v. Just before collision, only bullet is moving with a velocity. The bob is at rest. So here I can get the velocity v. Then what is the second idea here? Second idea will be here. So from this instant to this instant. So I can apply the conservation of mechanical energy. This is conservation of linear momentum, remember. Now I apply conservation of mechanical energy. Conservation of mechanical energy. The final energy will be is equal to initial energy. Final energy, it has potential energy only, that is m plus m into gh. Initial energy, it has the only kinetic energy, half mv square. So obviously from this, what can I write? So height h will be is equal to v square by 2g. You can remember it as a standard expression. If some object is raised from some lower to higher, then height raised is given by h is equal to v square by 2g. Okay. So from here I can get what is so called v value. So v value I can substitute here. So that means h will be is equal to, so by 2g will be here. So v square means m square u square by m plus m whole square. Okay. So let us substitute all the values. H will be is equal to, you can remember this is the standard formula for height rise in the simple pendulum case, 2 into 10. So mass into velocity. Mass of the bullet is given as 10 power minus 2. whose velocity is given as 2 into 10 square divided by m plus m whole square. I'll write m plus m and then whole square. So 1 kg plus 10 power minus 2 kg. The height raised will comes out to be h will be is equal to, so here it is 1 by 20. In the numerator approximately it is 10 power 2 and 10 power minus 2 cancel. It says 2 square will be approximately 4. In the denominator it will be, so 1 plus 0.01 whole square, 0.01 plus 1, so plus 1 whole square. So in the denominator entire thing I can take as simply around 1, because this entire results comes out to be 1 only. So then what will be the answer? H is, so 4 divided by 20, so 1 by 5, 1 by 5 approximately it is 0.2. Okay, so this is the easiest way of solving this type of problems. You remember the ideas. Okay, thank you.